Dear students, let us move to another topics from the photochemistry. Today, I will introduce you one of the important topics from the photochemistry. That is the foundation for many calculations, probably from your practical calculation, or this concept will be required for doing any projects in your BSc level. Therefore, please keep this idea very clear in your mind. You can solve a lot of questions, a lot of practicals, a lot of experiments using this idea. Therefore, I will take a little bit of time to explain this law. The topic is Beer-Lambert's law. The first, I will state the law here. Many textbooks have the lack of the clarity of explanation of this law. Therefore, I will explain and make it clear as possible as myself. And if you have any doubts, we can discuss it in later. Okay. The law is that when a monochromatic light passes through a solution containing absorbing substances, the decrease in the intensity of the light, the decrease in the intensity of the light is directly proportional to the concentration, the path length and intensity of the incident light. Okay. Therefore, the decrease in intensity. What is the meaning? Suppose you have a cuvette like this. This is called a cuvette. Here you have the solution. With absorbing media, absorbing substance. You have the solution like this. And this distance is called the path length. L is called the path length or size or length of the cuvette. Okay. Now you have a radiation with intensity I0 and get transmitted as I0 greater than I. Okay. Yes. The decrease in intensity depends upon the path length, concentration and the intensity of the incident light. This is Beer-Lambert's law. Okay. Now we can go to the derivation of Beer-Lambert's law. Derivation of Beer-Lambert's law. Derivation of Beer-Lambert's law. Derivation of Beer-Lambert's law. Suppose you divide this cuvette into imaginary small cuvettes like this, okay, with a path length distance dl. Okay, now your light is enter into this small cuvette and coming here and getting out and coming here like that. Okay, in each passage there will be decrease in intensity, that is called di, decrease in intensity. minus di, because why minus? Because this final, suppose this is smaller than this, therefore the difference will be final minus initial will be negative. To overtake that negative, you put a negative sign here, because we are only interested in the magnitude of the intensity. Di is directly proportional to concentration of the medium. Similarly, the decrease in directly proportional to dl, path length of the medium, and this is also proportional to intensity of the light which is incident. Therefore, we can make minus di directly proportional to ci dl or dl, or minus di is equal to k ci dl. Now I just rearrange. Minus di by I is equal to k c dl. This is the decrease in intensity for this small cuvette or small segment. Therefore, for the entire cuvette, we can integrate it. That is, you integrate from I0 to I, di by I is equal to k into c. C's concentration is uniform for entire cuvettes as well as smaller cuvettes. Therefore, it is also constant. dl from 0 to L. This is a larger length, L, dl. When you integrate, this is minus ln I0 to I is equal to kcl. Minus ln, you will get I0 minus I is equal to kcl. Minus ln I0 by I is equal to kcl. You will get like this. Now we can make it logarithm table. Therefore it will be 2.303 log I0 by I is equal to kcl. Therefore log I0 by I is equal to k by 2.303 cl, or log I0 by I is equal to epsilon cl, where epsilon is equal to k by 2.303. This epsilon is called molar absorptivity. Epsilon is called molar absorptivity. What is epsilon? Molar absorptivity, where epsilon is called molar absorptivity or absorption coefficient. Log I0 by I is called A, or called absorbance. Therefore, this is the Beer-Lambert's law. Absorbance is equal to epsilon cl. Okay, this is what is we call the Beer-Lambert's law. Okay. Now, Now, suppose T is a transmission. T is called a transmission of light. That is, this is a ratio of transmitted light to the incident light. Therefore, relation between A is equal to log 1 pi t. This is a relation between transmission and because we know that A is equal to log I0 by I, or A is equal to log 1 upon I by I0. This is a correct. Or A is equal to log 1 pi t. This is a relation between transmission and absorbance. Absorbance is A log I0 by I. T is equal to, transmission is equal to I upon I0. Absorbance is equal to log I0 upon I. Transmission is equal to I upon I0. Therefore, this is a relation between them. Or we can write like this: A is equal to minus log T. Or T is equal to T is equal to 10 raised to antilog 10 raised minus a, or T is equal to 10 raised minus epsilon C E C A. This is also the relation of transmission. Now I introduce you another very important concept. You will learn that lambda maximum of this substance, lambda maximum of particular substance is 200 nanometer, like that. What is a lambda maximum? Suppose you plot a wavelength versus molar absorptivity, you will get this type of a curve like this, a peak like this, and at this particular wavelength they have maximum absorption. That is called a lambda maximum. Lambda maximum is the wavelength at which maximum absorption of take place. Maximum absorption of a substance take place. That is, a particular substance will be absorbed maximum that particular wavelength. This is called a lambda maximum. Now, the limitations of Beer-Lambert's law. This is applicable to limitations of Beer-Lambert's law. One is applicable to very dilute solution. Okay. Second, applicable to monochromatic light. Applicable to monochromatic light. What is a monochromatic light? Same wavelength. Applicable to monochromatic light. Third is no scattering of light take place. No scattering of light by sample take place. That should not take place. The fourth one is no fluorescence or phosphorescence. Now, what are the applications of Beer-Lambert's law? Applications. First, determination of concentration of unknown substances. Dear students, you will do this in calorimetry. Therefore, this Beer-Lambert's law will be dealt in detail as a practical sense in calorimetry experiments. Therefore, that's a practical experiment in physical chemistry practical syllabus. Therefore, very careful. Here you will use Beer-Lambert's law for the determination of unknown substances. Similarly, determination of absorbance of unknown substances. Determination of absorbance of unknown substances. You can get the concentration of unknown and determination. What is the logic? I will tell you that logic. Suppose you want to know the concentration of an unknown. Concentration of unknown. For that, first you will get the absorbance. And it's known. Concentration of known. Absorbance of known and concentration of known. Because you have E is equal to epsilon Cl. You will use same QH. Therefore, known. This is also known. Get the value. Then you have an unknown. EC unknown L. Use the unknown in same QH, therefore length and length will be cancelled. Absorbance, same absorbance. Substance is same, but you don't know the concentration. Substance is same, but you don't know the concentration. Therefore, for same substances, epsilon and epsilon are same. Therefore, you will get, suppose you have a solution, suppose a salt solution, 1 molar salt solution. Concentration is known, 1 molar. Show its absorbance. Now you have an unknown salt solution. Its concentration is known now. Please determine its absorbance. That you will know how to do this in practical classes. Then you calculate that value. You get the absorbance there. Then you get a relation like this. Okay. You know the absorbance of known as well as unknown. You also know the concentration of known. Therefore, you can calculate the concentration of unknown. This is the foundation of our practical exam in calorimetry. Okay. Now, what is the unit of molar absorptivity. That's also very important. What is the unit of molar absorptivity? Unit of epsilon. That is, our relation is a unit of epsilon. A is equal to ECL. A has no unit because it is log I0 by I. I and I0 are same unit, therefore no unit. Therefore, this is 1 CL is equal to epsilon. What is C is equal to gram per ml, L is equal to centimeter. Therefore, epsilon is equal to gram raised to minus 1 milliliter into centimeter raised to minus 1. Suppose concentration is mole per liter, or if it is mole per, this is a unit of concentration, that is, suppose concentration epsilon is equal to 1 by Cl, epsilon is equal to 1 by mole liter raised to minus 1, this is suppose centimeter, therefore the unit will be mole raised to minus 1 liter centimeter. Therefore, this is the unit of molar absorptivity, this is the unit of absorption coefficient in gram. Okay, now we can solve one question. Let me check the video. Okay, video is going well. Yes. A solution of enzyme has an absorbent. A solution of amino acid has an absorbance at 280 nanometer of 0.54 in a 0.5 centimeter cuvette, length cuvette. You will see that cuvette, a small glass apparatus where the absorbance solution is taken. The absorbance coefficient is 5.4 into 10 raised to minus 3, 10 raised to 3 liter mole raised to minus 1 centimeter minus 1. Therefore, it's a molar absorption coefficient. What is the concentration? What is the concentration of solution? Very simple. A is equal to E epsilon Cl. C is equal to A by epsilon L. What is a 0.54? Epsilon is 5.4 into 10 raised to 3. L is 0.5. Okay. Yes. 5.4. Final answer is, you can calculate at this point. 402 mole per. Okay, you can calculate. This is solve this calculation here. .4 into 10 raised to minus 1 divided by 5.4 into 10 raised to 3 into 0.5. This is cancelled. Therefore, concentration is 10 raised to minus 1 into 10 raised to minus 3 into 1.5. 2 into 10 raised to minus 4 mole per liter. Okay. Thank you for watching. If you have any doubts, we can discuss it.